Okay, so today we're going to do 4-7. We're going to start it with our inverse trig functions. You'll work on what you can of the homework. Hopefully we'll get through all of it and we can get it on track again. It's not hard. It's not long. Like the process of each problem is not long. Does that make sense? Well, you have to, we'll talk about it. Okay, so we have this picture and this is sine, yes? This is sine right here? Okay, so sine is a continuous function that goes on and on and on and on forever. Now we've done inverses already this year, and inverse trig functions switch the domain and range so we're able to solve things and do things with them, like exponential to log, log to exponential, that kind of stuff. Yeah. But they have to be one-to-one. The functions have to be one-to-one, meaning it is a function, every x has one y, but the other one is every y has one x. So to tell you if it is a function, it has to pass the vertical line test. Does this pass the vertical line test? Yes. Okay. But one-to-one, it also has to pass the what? Horizontal. Does it do that? No. It fails. It fails bad, doesn't it?
Not even.
Okay. So what we're going to do is we're going to limit the domain of sine. We're going to say it's not all real numbers anymore. We're going to chop it to make it one-to-one. Okay? So I'm going to cut it off right here. Chop. Okay? So we're doing good. Now, if it keeps going, this can't happen, right? So where do if I cut it at 0, where do I have to cut it again to make sure I'm not repeating anything? 2 pi. Okay, that curve right there, does that pass the vertical line test? Yes. Does it pass the horizontal line test? Not yet. Okay. Well,
cut it a little farther.
Well, what happens if I cut it here? It's still, and then I don't have the negative values either, do I?
You can go back.
Okay, so I got to have the origin. That's the rule. I have to have the origin.
Oh, that's nice.
So where can I cut it so I have all the x, the max and the min? So if I take this and cut it right here and right here, do I have all the positives and all the negatives? Yeah, I do, don't I? So I took it and made my domain from all real numbers to what? Negative pi over 2. And it can't be equal, well, yeah, it can't be equal to negative pi over 2, sorry. And what? Positive pi over 2. So we are going to limit, we're going to have limited domains. Okay, so for sine of theta, give yourself 2 curves. And then we're going to cut it here and here, because we can do that. We can limit it, right? And change the domain to, again, if you wrote it already down, then you don't have to rewrite it. We're changing that domain to x such that negative pi over 2 is less than equal to x, which is less than equal to pi over 2. And evidently I decided to go slanted with that. So if I do that, now I have this picture. That looks like what? Like kind of. No, it just, I don't know, whatever you think. It kind of looks like tangent, right? It's not as curvy as tangent, but it's still, so if you want to miss this. And then we still have to mark what? -1 and
-2, -1,
+1 and 0. But that gives me every single sine and cosine value at one time, right? It doesn't give it twice, it only gives it once. What quadrants are those? Okay, so if I make a circle over here, we need to think about this. What quadrants did I limit it to? From 0 to pi/2, what quadrant's that? Quadrant 1, right? So we're here. So we're going up. We can go up to pi/2, right? And we can't go around because it doesn't exist. Like, I can't keep going because nothing over here exists. So does quadrant 2 exist? No, it's gone. We got rid of it. Didn't we? Okay. Well, I need 0 to -pi/2. Negative is a negative angle, yes? So I don't go up, I what? I go down. So that's why it's -pi/2. Does quadrant 3 exist in my world anymore? No. Okay, now think of it about this. These do not exist. So that is why every angle is going to be an acute angle, because I can go up to pi/2 or down to -pi/2. Think about Christopher Columbus sailing off the edge of the earth. Can I sail off the edge of the earth and then come back up? No. Can I fall into the Grand Canyon and then walk up the other side? No. Okay, so again, guys, we're going to go up and we're going to go down. Okay. What it has to do with anything is these do not exist, is what I'm trying to tell you. Do not tell me that an angle over here is 11 pi/3 or 6. Because that's what pi/2 is and -pi/2 is. They're angles. Because the sine curve is the unit circle instead of a circular representation. It is a flat representation. It's unwound. Because the circle is on top of itself over and over and over again. The sine curve is just like you pull it and lay it out. So you're going around the unit circle. So pi/2 here is the same as pi/2 here. Okay. So cosine, think about cosine. Here's cosine. So the same rules apply. I've got to cut it where I have the origin, or the origin has to be included, okay? And I have to have all the positive and all the negatives, and it has to be consecutive.
What?
So could I cut it the same place we cut sine?
Yeah.
Why not?
You have to do it on a 0.
Because I have all the positives and no what? Negatives.
You do it at a
Oh,
0.
so you can
go-
start at 0. Yeah.
I can start at 0 and stop where? Pi. Do I have all the positives and all the negatives?
Yeah.
Yes. Okay, so I'm not going to go and draw this one. I'm going to just draw this one for cosine.
Wait, can you draw the middle one?
You want me to draw the middle one too? Okay, so we'll draw all three for the cosine. That's fine. I was going to draw the circle, but I wasn't going to draw the middle. That's okay. And we'll come back to the circle. I'm just drawing it so I can do it in order. Okay, so we're cutting this from 0 to what did we say?
0 to pi.
Pi. So when I graph it over here, it's going to basically look like the sine curve, right?
You flip backwards.
My one side always looks better than my other. I don't even think I marked you absent. Thank you.
How does this seem you're sleeping? Nothing.
What's up, Alex?
So 0, pi, and then 1 and what? -1. So what quadrants am I in now? So I'm going to go back over here.
Is it?
I'm in the, well, this is pi over 2, isn't it? Right here?
Yeah.
Yeah, because cosine 0 at pi over 2. So I'm going to go up to pi over 2, and then am I going to keep going?
Yes.
To where?
0.
Not to 0, to pi.
Crap.
What quadrants don't exist anymore here? Quadrant 3 and 4. So our domain, our new domain, is x such that x such that 1 is less than equal to x, which is less than equal to, not 1, how about 0? I put the y. Pi, correct?
Yeah.
So what this does for
Wait,
me,
It doesn't go back and forth on the unit circle. It's just like the top one has 2 arrows, not moving. Like in the middle between parts.
oh, this one I can just go all the way over here. But on sine, I can only go up to pi over 2 or down to negative pi over 2. I can't keep going because you always start at 0, right? Okay. So what this does for me is I used to, when I asked where is sine 1/2 at, you had to tell me 30 and 150, right? Correct? Because positive 1/2 would be the first and the second quadrant.
Yes.
Does the second quadrant exist anymore for sine? So the only answer would be 30 degrees, wouldn't it? Or pi over 6. So you're only going to have one answer, not two. When we limit it, the way we know we limit it is this sign that's a lowercase becomes a uppercase. That's why when you guys were writing them with uppercases and I said, no, you cannot do that.
I don't remember that.
Well, some of you were doing it and others of you always did lowercase. Okay. Uppercase means it's a restricted domain. When I see an uppercase, the only thing that exists is the first and the fourth quadrant. If I see an uppercase C, what's the only thing that exists? What two quadrants?
The first and second.
First and second. So that tells me, it doesn't have to tell me anything else. I see the uppercase and I know exactly what it means. So now we got to do tangent. And we're not going to do secant and cosecant, and I'm not going to worry about that.
Yeah.
Tangent, no, because you just reciprocate them. And well, we're not going to worry about that. Okay, tangent of theta. And I put a capital T already, if you notice. And if you look at tangent, guys, it kind of naturally just does it already for you. Because I don't have one with just tangent. Shoot. Okay. No, I thought I made one for us. Tangent goes like this. Yes? and has an asymptote here. And if I just took this, do I have all the positives and negatives one time? Yeah. One period of tangent is already set up to do this in. I mean, it keeps going, right? But we don't want all of those. We only want one.
And it puts it in an asymptote for us.
And we don't, I don't like sometimes you'll see it go this way and they'll cut it like this. Does that work? Yeah. But is it continuous? No, there's an asymptote in the middle. Why would I want that? So we want continuous. So let's go here. Is that continuous? Yeah. Where's that between? Negative pi over 2 and pi over 2. So all we're going to see
Is that the same as
that is the same as what?
sine?
But there's one thing different. It's not an equal to. Why not? What is pi over 2 and pi over 2 for tangent?
What they have
They're
to
they're asymptotes. Can I be equal to an asymptote? No. So it's the only thing different that it's just not equal to.
yeah,
so-
because you can't touch an asymptote, I guess. 'cause
Can't?
It's gonna happen.
Oh, it's not. Okay,
It is.
so what two quadrants don't exist for tangent then?
1 and 4.
No, that's where it does exist.
Oh crap. Well, 2 and 3.
2 and 3. So I can go up to pi over 2 or down to negative pi over 2.
Yeah, 'cause it's like sine.
It's exactly like sine. So you really don't have to remember 3. You only have to remember how many?
2
Two.
and a half.
2 and a
You have to
half.
Remember the special domain.
Yep. Okay, so what that does to us, or for us, inverses help us because we can switch forms. Everyone got this down so I can move up? Okay. I'll move it up so it's a little easier to see. So we've limited our domains, actually limited the amount of answers we need to give, right? And there are ways we can write things. Now we got it? Good? Okay. So I'm going to ask for, if I put the sine of theta equals 1/2. You've answered this question before, yes? Well, right now it's lowercase. Yes. Kind of, yes. Okay. I've asked you the sine of theta is 1/2. I've asked you that before, right? So sine is positive in the first and the second quadrant. Sine is opposite. So what angle is opposite of 1 in your triangles? 30. So it's a 30-degree angle in the first quadrant, right? And then a second quadrant, it's what angle? 180 minus 30. 150. Okay, so that's what you've done in the past, right?
But quadrant 2 doesn't exist.
Quadrant 2 doesn't
It's fake.
exist anymore.
It's
So
only 30.
what they're going to do is they're going to say the inverse sine of 1/2. Well, remember inverses do what with these two things? No, not reciprocal. They switched places, right? So it's inverse sine, so that means I'm limited. So which one of these is my answer?
150.
Does quadrant 2 exist?
30.
Quadrant 1 is the only one. So it's 30 degrees, or for radians, pi over 6. The other way I could ask this question is arc sine. And the ACT loves to put arc sine on there because people forget that it means the inverse. All it's asking is where is the sine 1/2 at? Well, the answer is 30 and
30 and
pi over 6.
Gosh dang.
Okay, so inverse sine and arc sine mean the same thing, and all it's asking you is what angle is sine 1/2 at?
30.
Okay, so the inverse sign, and I think they use lowercase because anything inverse has to be, but if I'm talking about it in general, I'd have a capital. Inverse sign of negative square root of 3 over 2. So I'm negative, so what quadrant am I in? First or fourth? Fourth. Okay, and what's opposite is 60. So it'd be negative because I dropped pi over 3.
3.
Okay, so you can look at the assignment. You can probably do a few of them, but get yesterday's done for sure.
Is it due tomorrow though? Like, the assignment tonight?
For tomorrow, I will expect you, like tomorrow night, I'll expect you to have 4-7 done.
What?
4-7 done.
Four-
Tomorrow night,